Okay, so having said that, let's just go ahead and get started by loading our board file. So I'm going to go ahead and minimize our project. I'm going to go ahead and open the, I don't want to save this project. I want to go ahead and open my board file. So let's go ahead and find that. I believe it's under Documents, OrCAD, OrCAD Tutorial, Allegro, and there's my board. And as I said before at the beginning of this video, you want to go ahead and make a backup of your board file in case you want to go back and restart, or if you wanted to experiment a lot and you want to be able to come back to a fresh new state, go ahead and make a backup. So I'm going to go ahead and load the board file, and notice that there is nothing because we haven't placed any parts. Before we do anything, we want to go ahead and set up some things that are important. So the very first order of business is to go to Setup, Design Parameters. Okay, for display for the rat's nest geometry, instead of jog, we want straight lines. That means when the rat lines are drawn, we always want it to be in straight lines. Let's see, we want to display plated holes, non-plated holes, thermal paths if we have any, biolabels, and that should be pretty much it for this tab. If we go under the design tab, notice that here we can set the units. By default they are in mils, and I usually like to work in mils, but sometimes you might want to switch back and forth between millimeters or mils. You don't have to commit to one. You can work in one set of units, and then for whatever reason you can come back to this panel and switch the units to a different set of linear units. But I can leave this as mils. Line lock direction, make sure it's set to 45 degrees so that way we can make 45-degree turns as needed. And I think that's pretty much it for now. Under the Shapes tab, we want to go into Edit Global Dynamic Shape Parameters, and under Void Controls, we want to make sure that the artwork format is set to Gerber RS274X, which is the Gerber format that we want to generate when we generate the Gerber files. But we're not going to do that just yet. We just want to settle this up, and let's see. We click OK here. If we go back to display, we can also set up the grids here, or we could go to setup grids and it'll take us to the same panel. Alright, and as I had mentioned earlier, we can have we have different grid settings that apply depending on what we're doing. If we're placing parts, etch usually means is synonymous with copper. Any copper feature is etched, is created through an etching process, so that's why we call such things as etch versus non-etch. So when we're placing parts, we have a larger grid granularity or resolution. But when we're doing things with the top and bottom layers, for example, then the resolution of the grid spacing is a little bit more finer. You can change those here. The all etch will override the individual settings for the top and bottom layer, so that's why it's usually left blank. But just know that that's here in case you needed to change these settings. But I'm not gonna do anything like that at the present moment, so we'll just leave it the default. And we click apply, click OK, and we want to do a Control S to save. That's another thing. You want to make sure that you're constantly saving, just in case something happens. You want to make sure that we can restart from a recently saved file. I've seen cases where students will go very far, forget to save, and then sometimes the program will crash for whatever reason. You want to be able to restore your files from a recently saved board file. Okay, that gets us ready to go, and we can just now move on to you need to make a decision as to how many layers you're going to use. Remember, again, for that we go into the cross section or the layer cross section panel, which defines the layer stack up. Okay, right now I have this a two-layer design, so I have a copper layer on the one side and then another copper layer on the bottom side. I have a dielectric. FR4 is a very common PCB material, so this by default is already ready to go for us. If you wanted to, as I already showed you, if you wanted to create like a 4-layer design and 6-layer design, 8-layer design, whatever, you can just right click and you can add layers, and then you can set the type, whether it's a dielectric or conductor, and then the material type as needed. But just be mindful that that is here. There's nothing for us to do here, so I can just connect, click cancel since I haven't done anything. And at that point, I am pretty much ready to start placing parts. So to place parts, first I'm going to turn the grid on by hitting F10. Okay, and then I click on the place manual icon here on the very far left. Okay, then the placement panel comes up, and I have a list of components of the footprints that I have assigned that are related to my design in my schematic here. Everything has a footprint, and the board has that information, and that's why I have these specific files in here. Okay, so the first thing you want to do is you just want to place these files, and you don't want to worry about exact placement. You just want to make sure that you have placed all the files. So we go ahead and we click on a particular component, and basically you click anywhere in your design area. So I click here, and while I'm here I'm going to zoom in a little bit closer, and notice once again that I have a lot of information that I don't need, but we'll worry about that just in a minute here. We'll take care of that. So let's just go ahead and place the components. We have J1, J2, J3, we have the power here, and then we have the logic chip components. So we're just gonna go ahead and place these on my design area. I don't care very much right now about their proper placement. I'm just placing all my components in my design area. Notice that as I place components, I have a P indicating that the part has been placed. Okay, we are done placing parts, so I'm going to go ahead and click OK. Alright, so again, middle mouse button, we can pan around. First thing I want to do is I want to clean all the clutter. I don't need this much information. So what I'm going to do is I'm going to open the color dialog, Control F5. Let me bring that in. And I showed you already this earlier. So we go under components. This is for component information. And I want to turn everything off, and the only thing I want is the component value for the silkscreen layers, bottom and top, and the reference designators for the silkscreen layers as well, bottom and top. We click apply, click OK to dismiss it, and notice that now everything's much cleaner. Okay, next thing we want to do is we want to reveal the ratlines for the power pin. So here I have BCC and ground, but mysteriously I don't have the ratlines. Okay, you want to show all the ratlines. We don't want to forget about completing these connections. So once again, we go to the constraint manager, and we go under properties, under net general properties. We have all the net labels that we're going to have to connect. And under no rat, notice that we have for ground and for BCC, they're hidden. We don't want to do that, so we're going to clear these settings here, clear them here, and then we can go ahead and dismiss the window. There's nothing to say OK or enter or whatever. It happens automatically. So we dismiss the window, and notice now that I have BCC and ground. They have the corresponding rat lines. Alright, so now we want to go ahead and we want to start arranging the parts in some sort of logical manner. And the decision is usually based, there are many rules, particularly, where you're doing digital design, or where you're dealing with analog domain design, or whether you're doing mixed signal design, or whether this design includes corresponds with high-speed designs. There's a variety of rules that you got to follow. Because this is a very elementary circuit, I'm going to keep things simple and straightforward, and just for the purposes of showing. But know that there's sort of like both an art and science, and a lot of research behind what constitutes a proper placement of parts, and the laying out of parts, and the traces, and the distribution of power, etc., etc. Okay, so there's a lot of information that we're skipping for the purposes of just demonstrating using OrCAD PCB Editor. But anyways, let's just go ahead and move parts. We're going to move parts. Remember, to move part, we enter move mode, Shift F6. Okay, so I'm going to go ahead. Again, I'm using the shortcuts most of the time. Notice that on the left hand corner, I have the move tool engaged. Okay, and so when you click a part, you can go ahead and move it. And the decision, basically, how you arrange parts is you want to minimize the distance between most rat lines to the part. Notice I have 3 rat lines that go to this device here, and therefore it makes sense that I keep it close to this component right here. Okay, this device here, notice that the rat lines mostly connect to U1, therefore it makes sense that I keep this close to U1. Alright, then we have U2 here. It looks like it's connected to both U1 and U2, so maybe it makes sense that I move my component right here. Then I have U5 here. It seems that it's pretty safe if I move it here, and then I have U6, and it looks like it's a little bit of each, so I'm gonna just put it right in the middle right here. And then for the output connectors, I'm gonna place this, so these actually, you know what, I can put that right there, and this component here, once again, I can put that right there. In fact, just to keep things nice and symmetrical, I'm just going to put it right here. And then we have the power pin here. I'm just going to go ahead and put in here. And one thing I want to point out, how you organize this is up to you. This is one example of out of the infinite possibilities of permutations in which you can organize these parts. Okay, so this is just one possibility. But what I need you to keep in mind is that as you're placing parts, you need to be fully aware of the physical size of the component. Okay, and this is what usually this boundary, this shaded rectangle around my part is supposed to signify what is the approximate shape of the component. But you need to, based on the components you have chosen to use, you need to be aware of what the size of the component is, so that you can leave sufficient size spacing around the component so that your component doesn't bump into another component when you put them on the board. And also you need to keep in mind about traces. If I'm going to be laying traces around, I can obviously lay traces underneath the part, and we may need to lay some traces in between the parts. So you need to leave some spacing so that you can account for the possibility of moving, laying out traces in between the two parts. So that's always to keep in mind. And in fact, let me show you something that because I really need you to keep this in mind. So for example, suppose you look at a relay. Maybe you have 3 pins. Suppose we have a relay symbol here. Maybe a double throw relay, and you have the coil. So this is the symbol for the relay, and maybe this is pin 1, 2, 3, 4, and 5, right? And then you find a 5 a pin footprint. First of all, you need to consider the physical dimension of the relay. Maybe it might be sort of like a rectangular box like this, right? And maybe you have 1, 2, 3, 4, 5, right? And if we look at the footprint for that, we might have 1, 2, 3, 4, 5. Okay, so this is what the footprint looks like. But just because the footprint occupies this much space doesn't necessarily mean that the part also occupies this much space. So you have to be careful. For example, if I let's see, if I copy this and paste it to simulate me placing another component right next to it, okay, you have to be aware of what the size is going to be, right? If the actual physical size of the component is that, then maybe we're safe. Maybe I can place the footprints that close to each other for relay 1 and relay 2. Okay, but if that's not the case, what if this relay was much bigger? What if this relay was this big and the footprint was exactly the same, but the physical size of the body was much bigger, right? If we have this, then obviously you're gonna have a problem, because now you place these two footprints way too close to each other. You did not account for the actual physical shape of the component itself, and therefore you will not be able to actually place your component on the board when you get it. And this is a pretty much a catastrophic error on your part, and that's why you have to be aware of both the physical size of the component, and also whether the footprint matches your part. So for example, here I have pins 1, 2, 3, and 4, 5. Well, maybe this could be one possible pin assignment for your component. So when you look at the footprint and you inspect the pin numbers, do the pin numbers match the pin numbers on the data sheet? Okay, maybe a different arrangement might be counterclockwise, 1, 2, 3, 4, 5. Yes, the footprint, both of these footprints fit this part, but the pin assignment is completely different. So if your symbol pin assignment and the footprint pin assignment do not match the pin assignment that is on the data sheet of your particular component, that's going to be another catastrophic failure, right? And your board is not going to work, even though the component sits nicely on the footprint itself. So that's something to do, a very easy way that you can get into a lot of trouble. So just keep that in mind. Okay, so I have all my components placed. This is the way that I'm going to call it. This is the way I like to keep it. While I'm moving stuff around, I want to hide the rat lines. So you could do this. You have these two icons here on rats all, rats all. If I on rats all, I can hide all of the rat lines, and I'm just looking at my components. Okay. Now I want to go ahead. I want to move just the text. So that I can position the text and so that it's more presentable. So again, we're in idle mode. When we're moving text, you actually do not have to enter move tool by hitting here F6, because if I do that, then let me just show you. If I enter move mode and I try to move this text, instead the whole component moves. We don't want to do that. We want to cancel. We want to be in idle mode, and in idle mode I can actually select the text just by itself and I can move it around. Okay, let's see. Well, and I want to go ahead and notice my grid settings are too widely spaced apart. So I'm going to go back into grids. I'm going to change this to maybe 50, 50, and click OK. And let me turn the grids on again. And so I can just go ahead and place it, right there. Would be good. I still don't have enough fine grids. Let me change that to 25, 25 for the time being. I want to be able to move it with finer resolution. That's why. So I have that there. That looks pretty good right there already. U4, let's move it right there. U1, let's move it right there. Let's move it right there. And be consistent. Notice that I have everything on the upper left corner. Component value, I'll move it right here in the center. Right there. Component value for this guy, I'll move it right there. Component value right there. Component value right there. Reference designator right there. Reference designator right there. Okay, I'm pretty happy with that. Let me turn off the grid so you can see it. Alright, I'm going to go ahead and go back to the grids and put it to where it was. And again, this is an example where I told you this is something that you might have to go back and forth. Alright, so I'm pretty happy with this. Now I'm going to put a board outline. Okay, to do so we go on to setup. Let's see, outlines, board outline. You click on board outline. The board outline panel comes up and is presently in the create mode. For the board clearance, usually I think that we can get away with 100 mils. 400 mils is too wide of a gap between the edge of the board and the key pin region designated by the board. So once this is open, I can actually click here. once, and then I can draw a rectangle around my board. And when I do the second click, it will draw the outline. Notice that my board outline is in edit mode. That means I can come back in these corner points or vertices and I can edit the board. So for example, here maybe I can expand this. Oh, that did not work. Let's see. There we go. Alright, once you're happy with that, you're going to click close or apply, then close. Just close. And then notice that I have my package keeping region, and on top of the package keeping region there's also the routing keeping region. Alright, so my parts have to be inside of this region and my traces have to be inside of that region, otherwise I get a design error. Okay, we're almost ready to start laying out traces. Next thing we got to do is, I said every board needs a defined origin. Alright, and that origin has to correspond with the bottom left hand corner of your board. To do that, we want to go ahead in setup and we want to change drawing origin. So you click on there once and then we click here and boom, the origin is now, notice here on my coordinates I get 0, 0 when I hover my mouse over the origin. So that's good to go there. Okay, next thing that we could do at this point before we start laying out any traces is maybe we need mounting holes for our board. You know, if you put mounting holes, then you could put hex standoffs. See if I can show you hex standoffs. Right, they look like this. Let's see, and let me say PCB hex standoffs. Like you can see, I want to show you. You know, these standoffs, you can put them on your board, and then if you have your bare PCB, oh, here's a perfect picture, sort of. You know, you could place your component on these standoffs, and then that way when you put it on the surface of a desk or something, you don't have the bare board scrubbing against the surface of your bench. And that way the standoffs keep it elevated from your surface. Okay, so mounting holes is a good idea, and to do that basically you go back onto the place manual. Okay, let's see what's going on here. There we go. Place manual, we want to go into mechanical symbols and we want to go into advanced settings tab and we want to engage the library. Go back to placement and now we can expand the mechanical. The MTGs for the mounting holes, and usually a mounting hole 125 mils wide should be sufficient. So if I click on this and I can go ahead and place the mounting hole there, notice that we got a bit of a problem. That if I want to put 4 of these, I may need to move my parts around, and that's okay. Or I could edit my in fact, let's do that. Let me cancel. Let me hit the escape key, and let's edit the board. So we go back to setup, outline, board outline, and we're gonna edit it. I'm gonna make this a little bit bigger. So I'm gonna drag this. Let's see, edit. Move. No, let's not do that. Setup, outline, board outline. I should be able to drag. Why can't I drag? That's not what I wanted to do. Cancel. Let's go back. Display. Setup. Outlines. Board outline. Click. That's not working. Cancel. So I cannot move it. Alright. Fine by me. Control D. Control D. Control D. All this stuff. And let's draw a new outline. Setup, outline, board outline, create, yes. Let's make a bigger board outline. And we'll need to move the origin. Click apply, oh sorry, close. Oh, I did not adjust the, let's do that again. I did not adjust the spacing. Setup, outline, board outline, create. Click it there. Let's change this to 100 mils and close, and there we have it. Now we have enough room for our mounting holes. So I'm going to go ahead and place component, advance, engage the library, go back to placement, expand, click on mounting hole. We'll put that one right there. Click on mounting hole again, put one right there. Click on mounting hole again, put one right there. Click on mounting hole again, put one right there. We're good to go. Click OK. We need to redefine the origin because I changed the board size. So once again, we go on to setup, change drawing origin, and click there. Okay. There we have a board outline. Our parts are ready to go. Let's do a Control S to save. Yes. And at this point, we're ready to begin the adding of the traces. But before we do that, we need to set the constraints in the constraint manager. Okay, so let's go ahead and do that. Okay, so at this point we're ready to start laying out the traces. So the first thing we got to do, however, is we have to set up the constraint manager. So we're going to go back to the constraint manager, and by clicking on the constraint manager icon, and now here we need to define physical characteristics of the traces. How wide are our traces going to be? So we click all layers here. We can set the minimum line width. Okay, so this is a very simple design with using pin dips, chips. You know, we could use pretty wide traces. So I can actually, I feel comfortable just saying, 50 mils of line width. For the necking, we're not going to do any necking, so we're just going to also make this 50 mils right there. So I'm actually entering the number and hitting the tab key. 0 means that there is no maximum limitation. Okay, and if it's 0, leave it at 0. Blind buried bias, 15 there also, and that should be good. So this does it for all of the lines. Then we can go on to here on a net by net basis. If I click on net, notice it says it's 15 here, but I want to change my power lines to be thicker. So for ground and BCC, I'm going to make the minimum line width 30 mils. 30 mils there. Let's see, same here, 30 mils. 30 mils. What else? Then we have 30 mils there, and BCC 30 mils tab. Okay, so that sets the width of the system. The traces. Then there's a spacing between traces, or spacing between copper features. How close can one copper feature get to another copper feature? So we could do all layers. Let's see, spacing constraints between a line to a line to a through-hole pin, a line. How close can a line get to a surface mount device pin? How close can a line get to a test pin? How close can a line get to a through-hole via, etc., etc. So you could set, you have a lot of control in here on how to set that. But then you have to repeat the process. For example, then you can go pins. So then how close can the pin get to all of these possible elements? How close can an SMD pin get close to all of these design elements? How close can a test pin get close to all of these design elements, etc., etc. So usually the best approach is just to go to hit all, right? And notice that everything says 5 mils, and usually that's okay. But you need to check with your PCB manufacturer. Every PCB manufacturer has a set of constraints of how much spacing, how wide can the traces be, how small can they be, how close can any feature get to another feature, and the manufacturer will state this in their website. Okay, so you need to search, and once you find manufacturers that you think you're going to go with and whose price is within your price range, then you also need to check what their constraints are, and then based on their constraints, then you make the decision on how far you're willing to push these physical limitations and apply them to your constraints. So for safety, just to show you, let's suppose that the safest bet is usually to go 7 mils, although most benders will allow 5 mil minimum spacing. So I'm going to change everything to 7. And notice eventually, as I move along, some of these already have 7s because this is organized sort of like in a comparison matrix, which would have been easier to understand. Let's see. So 7, 7, 7. I just want to play it safe. 7, 7, 7. And 7, 7, and one more 7, and these are okay. 7. Alright, so that's for the spacing between traces, and then how close can the same net get to itself, right? This is the same situation, the exact same conditions. So we go to all, and right now the default is that all are 5 mils. So again, I want to play it safe, so I'm just going to change all of these to 7 mils pretty much across the board. It's set for, let me scroll all the way to the end, make sure that I know. Okay, 7, 7, 7 all the way. Okay, 2 more, 7, 7, and 7 right there. Okay. My constraints are set. So I have for constraints for my power lines, for physical spacing, etc., etc. So we are ready to begin here. I can go ahead and dismiss this, and again, Control S to save your board. And we can now start laying out traces. So to lay out traces, we want to go ahead and reveal again all the rats, which I had them hidden previously by hitting on rats all, but now we want to rats all, and all of my traces appear. Okay, there's something I want to start with my power and ground here, and I want to start laying out these traces for power and ground. In a sort of star topology manner. So to do that, we want to go ahead and add a connect. This is basically the terminology for adding a trace, and you can actually hit F3 on your keyboard as a shortcut. There's one thing I want to show you. You know, all these rat lines, they get in the way. There's too many rat lines. Even though they are helpful, it would be nice if I could just see the BCC and ground rat lines, since I'm only going to work on these. To do that, there's actually a way to do that. We can actually unhide all rats, and then I can go here. Let's see if I can remember. Display show rats by net. Okay, so if I hit that and then I click on BCC, notice that now I have the rats for all my BCCs visible, and I can focus my attention to only completing the traces for an individual net and not be distracted by any other rat lines. So therefore, I'm good to go there. Notice that I'm still in rat nets mode. it's engaged. Remember, every tool you have to either done, oops, or cancel. So I'm going to do a done so that I can exit the rat's visibility mode. I'm going to hit F3 to add connect. And notice that the grid spacing changes to the default of 25 mils from 100 mils. I'm going to go ahead and start laying out. Now, notice that the option panel has the top layer, you know, what is going to be my default. My active layer is the top layer, and my alternate layer is my bottom layer. Okay. If you want to start from the bottom layer, you can right click and we can swap layers. And if I swap layers, now I'm on the bottom layer. So my active layer is the bottom layer and my alternate layer is the top layer. Okay, I'm going to go back. I'm going to do swap layers and go to the top because I want to start from the top. Now, when you're doing traces manually, a very safe strategy is to constrain your traces to be orientation to be horizontal in one layer and then vertical in another layer. So for example, if I'm moving from one pin from here, maybe I want to make a connection from this pin to this pin, what I do is that I lay out a trace and I constrain, and let me start that, that was not very good. I lay out a trace, maybe I can come down a little bit, but I lay out a trace horizontally on layer 1. Then what I do is I insert a via, and then I move on to, let me change the color here to blue to denote the other layer, right? And then in the bottom layer, I constrain my motions into vertical lines. Okay, so then once again, if I'm on my top layer, and let's say I have another pin here, and I have another pin here, then I can go ahead and I can come down here, back down. And suppose I'm blocked and I'm forced to go down, so then I insert the via here, then I move to the bottom layer, and then I can go through there, and then I insert another via there, and then I move on to the top layer, and then I do a horizontal move. I notice that because I'm constraining my motion, my traces in one orientation that are mostly orthogonal to each other, I don't block myself out. Okay, so I can keep playing this game. I can continue to lay out traces as much as I like, right? And then in the other layer, I can go ahead and lay out traces in this direction, and I never block myself out because you know, you have these separated into two layers. If you don't do that, you are bound to eventually, if I do this, you know, and then you connect these two pins, and then let's say you needed to connect these two pins, you're out of room. Either you will have to come way around here, assuming that you have any room to move into, or you may be completely blocked. Suppose I have another pin, what do I do next? And I got to do this. Then I have to do this, come back around, and do that. And eventually you will run out of room very quickly if you don't follow this strategy. Okay, so, and this is something that you will get better at as you practice more and more. Alright, but let's just go ahead and just start laying out some traces. So I'm going to do, let's see, so power and ground. That's power right there, that's power right there. So let's just go ahead and do that. So again, here I'm going to move down, and therefore I need to be on the other layer. So let's just do that. So I'm going to go into swap layers. I'm going to start in the bottom layer. I'm going to click there, and I'm laying out my trace. And actually I already see a problem that I don't like, that my traces are constrained to 90-degree angles. So I'm going to go ahead and do an oops. I'm going to go back and I'm going to put line lock to 45 degrees. And then I go ahead and click on that, and now I can move at a 45-degree angle there. I'm just going to go ahead and complete the trace there, since I'm so close to that. And then let's see, now I'm going to move horizontally, so I'm going to swap layers. Now I'm going to be on the top layer. I'm going to go ahead, and what I'm going to do is I'm going to do a motion here. I'm going to do sort of like a tree-like power distribution approach here. So I'm going to hook that there, and then I'm going to actually, because I'm very close here, I'm going to violate my rule a little bit. I'm just going to do a straight trace and drop that in there. Okay, now I'm going to move from here all the way down. In fact, from here all the way down, I'm going to repeat this process. So I'm going to swap layers, bottom layer. I'm going to double click to insert a via. There's a via, right? So now I'm on the underside, and I'm going to move down here, and once again I'm going to click on, double click. Now I'm on a top layer, but I'm going to move horizontally. So we have that, and then again, because I'm so close, I'm going to go ahead and violate my rule a little bit, and I'm going to stay in the same layer and hook that up. So at this point, let me turn the grid off, and again, right click, done. So we're done with this part. I'm going to Control S to save. Yes, so I'm done adding my BCC. Okay, now I want to do was it BCC? Yeah, BCC. I want to do ground. So once again, I go on to display, show rats, net. Let's go to ground, and now I can see where all my grounds need to be. Okay, so same strategy, right? I'm going to go ahead and add a connect, F3. Okay, and I'm going to start from the bottom layer. I'm going to move vertical in my bottom layer, and notice that because these two are on the same layer, I'm kind of blocked out. Okay, but that's okay. We just go ahead and come around here. Let's see, trying to choose a strategy. In fact, let's do this. Let's do this. So I'm going to lay out a double click via. I'm going to come in here, and I'm going to do another via here. I'm going to come down here, and I'm going to do another via there. And that way I can, while I'm doing this, I can use the middle mouse button to either zoom in or pan around. So I'm going to go ahead and I'm going to double click a via, so then I can move up and I can complete that. And then once again, I click in there. I'm still on the bottom layer and double click to insert a via, so that I can connect the bottom layer trace with the top layer trace going vertically. I did not do that here because these are on the same layer. Okay, but here, this layer is in the bottom. This layer, this trace is in the bottom. This trace is in the top. And so that I can join the traces electrically, I have to insert a via. Okay, from here I can actually go vertical. So once again, I swap layers, and I'm gonna continue from here. And since I'm not blocked, I can actually keep going that way. And once again, I can double click to insert a via and hook that guy there. And then once again, I swap my layers. I want to go back to the bottom. Double click, same strategy, double click, and I'm gonna oops, let's do, oops, we messed up there, and I accidentally hit cancel. I didn't mean to do that, but that's okay. F3. Okay, let's see, we want to start from the bottom layer. Oh, it's not in the bottom layer, I don't think. And then double click and double click, close that there, double click to insert a via because these are in opposite places. Right click, done. Control S, save. Okay, so at this point my power distribution is now in place. You know what, this doesn't look very pretty. Let's see, I want to go ahead and Control D to enter delete, and I'm going to click on this trace so I can delete it, and instead I'm going to F6 to exit the tool, then F3 to start a new connection, and I'm going to again violate my rule because I'm going to make very small motions. I'll come back here around there, and then double click to insert a via, and then we make it straight down here. That looks a little bit more presentable than what I had. Okay, done. Control S, yes. Alright, my power traces are in place. Now I can go ahead and start adding traces for the signals. So If I do a rats all to reveal what is left, okay, we can see everything. And at this point, you can just start adding traces. So let's see, where do we start? Let's start from J1. F3, add connect. Here, let's see. If I hit that there, I can make small motions. Actually, that's going straight down there, so just click there. Let's see. If I'm still in the bottom layer, so I click here to come down. Again, double click to insert a via. Finish that up. Alright, then swap layers. Finish that there, and looks like that has to go all the way over there, but I can go ahead and move down here, and then I insert a via, then I come across here through in between the pins, click there, that completes that. Then again, I want to be in the bottom layer, so I swap layers, I click. I want to keep these closed so that I have enough room for more traces if I need to get through. I want to block myself out. Double click and I make a horizontal motion. Right? Once again, if I need to go through here, I can, because I can go in the opposite direction. That's why you want to be very mindful about how you lay out your traces and restrict yourself. Notice that I need a connection from here to here. So once again, I want to be on the bottom layer. Click, then double click to move to the top layer. And there. Okay, as long as I follow my rules, I have room to move. Here I have this trace, I can move from here to here, so I'm on the top layer already, so I click here. Okay, maybe make a little diagonal movement there, you know, some minor diagonal movements are okay. Click there, that completes that. Let's see, looks like we need this pen. Where's it going? Let's go and do hide all, and let's do display show rats by net. Let's see, there was a pin here that needed to be connected. I can't see which one it was. If I do that, okay, let's take care of these. So here we gotta short these pins out. All right, so let's go ahead, F3. I'll actually drop the tool for the rats visibility, F3, bottom layer, swap layers. So I'm going to just make a shortcut here. So for the clock, and that goes there. And it looks like we need another one there. So I can either connect from here to here, or I can actually continue from here. Right, and once again, I know I'm close, but maybe I need to lay a trace in between there, so I want to make sure I can lay at least one more trace and hit that there. And then from there, we gotta hook these up. So I'm already on the top layer, so I'm gonna just lay out a trace and come in between these pins right there. Right, let's see. Double click to lay out and be on the bottom layer, and since I'm so close, I'm gonna leave it at the bottom layer and finish that there. Okay, once again, exit the tool, done, Control S, save, reveal all rat lines to see what we have left to do. Okay, we have some pins we gotta lay out, so let's just continue. Alright, F3, add a trace. I'm already in the bottom layer, and as I said before, I have room for one more trace in between here. Bada bing. Okay, we want to pan down. Alright, double click, connect. Okay, what else? Alright, we gotta go to the bottom layer, swap layers. I can steal a trace from here and span around there, click, double click, horizontal movement. Back here, swap layers, start from the bottom, we're moving down, right there, double click, oops, do it again. Okay, let's do an oops, something happened here. click, double click, there. Alright, what else? Looks like we have a line here. That makes no sense. Oh, we don't have a power pin connected. What is that? Let's see. Let's just leave it alone and we'll come back to that. Let's see, where does that go? Okay, I see what's happening. Alright, let's go top. I'm already on the top layer, so I'm going to lay out a trace in there and then double click to lay a vertical trace. And double click, finish it. And then here, let's see where that goes. It goes all the way there. So once again, I'm in the top layer, so click, double click, and double click there. And then let's see. Let's move on to, see, we looks like we got a trace from there to there. Okay, so let's just click there. I can come down here and I can squeeze in through those pins. There. Alright, where does this go? Over there. So once again, click, click, and click again. And we complete that trace there. Let's move back up here. Let's move from the top. So I'm going to swap layers, go to the bottom. Start here, click, move in this direction. Oh, that'll go straight there. But it also goes straight. So let's do a swap layers so that we can make a horizontal motion and then double click so that we can make a vertical motion. And in fact, since we're so close, I'm just going to complete it right there. Alright, these two need to be shorted together. So I'm already in the bottom layer. Alright, that's done. Let's see. Let's start with this one. So down there. Let's see. Let's just go ahead and add a bio right there. And there, it's done. Alright, this one, where are we going? So this goes all the way to the bottom. Right there. So let's go ahead and move to the bottom layer. Click there. Bring it close so that we have some room in case we need to do some additional traces. Let's pan down. And that takes care of that. Okay. Here we need to do horizontal motion so I can hook this up. So I'm going to go ahead and squeeze in through here. Double click. Now I can make a vertical motion and double click and horizontal motion, and that takes care of that. Here, same situation. So I'm gonna go ahead and make a horizontal motion here. Bring it right there. Double click and boom, we're there. Once again, here we're going way down there. So let's see. So I click there. I can certainly move around here. And let's see. Should I keep it away from? Alright, so where are we going? Right here. Double click. And we want to move around, snake around those pins. Boom, that's connected. Alright, what else? Let's see. I see some ratlines visibility here. So let's see. Let's swap layers. Okay, so we gonna immediately move on to a horizontal motion, vertical motion. Hook this in here and come down here. And we see here, same situation. So I'm just going to short these there. Okay, how are we doing? Let's save for now. Let's do done, Control S. And then as you get closer to finishing, you know, it might be harder and harder to see the rat lines. You know, one thing you want to be aware of, if we go to display, status, this is an important panel because it shows you how many unplaced symbols. We have no unplaced symbols. How many unrouted nets? There's only 7 nets left. We're almost 33% near completion. Okay, and your router connections are remaining. Okay, usually you want to do an update DRC to make sure that we don't have any violations. And looks like we're getting there. We're getting close. So we'll dismiss this and we'll continue laying out some traces here. Looks like these two have to be connected together. Let's see. Let's do an F3. Okay, and looks like we're gonna have to move here. So for the clock again, hit that there. And let's start here. Bottom motion, click bottom motion, and let's do a double click. Now we're in the top layer. That completes that. And let's see here. Looks like we can move. Let's start from the bottom layer. So we'll do bottom layer there. Click there, and then I can make another horizontal motion. Double click. We're on the top layer now. Snake through these pins. Click, click. That's taken care of. Looks like this rat line here. So we are already in the top layer. So top. We'll snake through here. Snake through there. Double click, and now again there, there, and click there and there. There we go. Okay. Looks like we have a rat net line right there. Let's move to the top layer. Swap layers. Click, 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 and click. Okay. Are we missing anything? Let's do a done. Let's do Control S. Yes. Once again, display status. We have two nets that are not visible. Where are they? Oh, there's one. Okay, so we have that rat line there. So F3, and we want to start on the bottom layer. So I'm gonna lay that out there and connect it there. Oh, and there's the other one. Click there and click there. Right click, done. Control S, save, yes. Display status, done. Nothing else to do. Let's update the DRC, make sure we don't have any errors. Sometimes the DRC will not immediately reflect the latest state of your board. And in that case, you want to click on update DRC and refresh. Make sure that everything's good. And everything indeed is good. We've done placing symbols, taking care of all nets and all the connections. Click OK, we zoom out, and our board is routed. Let's do another Control S. Yes. Alright. So let's see, where do we go from here? We're pretty much done. We can add some markings. Alright, so let's add some text. For example, you know, there's two icons here, one for adding the text and another one for editing the text once you have placed the text. Okay, so I'm going to click on text. I want to add text on the silk screen layer, in the same layer that the reference designators are located. See, if we go back here onto the options panel, presently the bottom copper layer is selected. I don't want to add text to the copper layer. I want to add text to the let's see, package, board geometry, and we want to do silk screen top. That's where we want it. Marker size, you can leave it at default. Okay, so if I click down here, you know, you can change the size if you don't like it. For example, University of Nebraska, Lincoln. Okay, again, we want to do next. If you want to add more text, you can't just hit enter and then have a new line. We need to add more information. Maybe let's see, let's click over here. Oh, my grid spacing. Once again, that grid spacing. Let's do a done. Notice that my U disappeared. Sometimes there's some weird graphic that needs refreshing. You can hit F5 to refresh the graphics. Anyways, before we add more text, I need finer granularity. So let's go to change the grids to maybe just 50 mils. Click OK. I hit the text tool, and I can click there. And maybe you can put your name, J Santos, and usually a revision number, rev dot 0.1. Okay, and then right click, done. Okay, so now I have that information. Suppose I wanted to put my name also underneath the board on the opposite side. Okay, you do the same thing. We have click the text tool. Let's say we put it on the top here. But now we need to go back here. Now we need to select the bottom silkscreen layer, right? But there's another thing we have to do. We have to mirror the text so that it has the right orientation when we're looking at it from the top. So if I click here, let's see, this is very strange. So once again, I just put J Santos. Okay, right click, done. And again, you just click and drag the text wherever you need it. Alright, but this is actually on the bottom silkscreen layer, and it's mirrored so that it goes in the right orientation. Notice that if I were to flip the board, there's a flip board icon here. If I flip the board, then I'm looking at it from the bottom side, and now that the text is oriented in the right way. Okay, so that's a way to verify that. Alright, and so we're done, ladies and gentlemen. Let's do one final save. Okay, so I'm going to stop the video here, and at this point the board is completed, it's fully routed. I have my mounting holes in place. Now the next step is to generate the artwork files, or what they're widely known as the Gerber files, which you submit to the PCB manufacturer so that they can manufacture your board. This requires that we juggle back and forth between the color dialog panel and the artwork panel for the artwork control form. But that will be a topic of another video. Okay, I'm going to do that separately. And so, actually, before I finish off, there's actually a few more things I want to show you. We are done, but there's some additional information that we can just add for to make it a little bit more professional, if you will, and that is adding dimensions for your board. Okay, remember this is sort of like a physical schematic. If this is a functional schematic of your design, but this is a physical schematic of your design. So we could add some what are called linear dimensions by entering the linear dimension edit tool. If we click on this and I do a right mouse click, now I have a series of tools that we can add to add information regarding the dimensions of your board. So if I have linear dimensions selected, which indeed I do, notice I enter the linear dimension tool and it shows you on the left hand corner. Once again, now we're in the active mode. So I'm going to go ahead and engage the grid, and I can click here once, click here again, and then I can elevate the units for the distance between those two edges, and now I have that in there. And then I can do the same thing for the side. Okay, so once again I can click in here once, and then I can click there again, and then I can position the measurement value in there, and there is my, let me turn it off, and now I have my dimensions. Remember to exit the tool, so done. Alright, and one last thing is usually some people, they add something called an NC drill legend. So if you go under manufacturer, NC drill, and we do NC drill legend. If I click on legend, then I can insert a legend in there. Okay, and you can just leave everything as the default. Alright, and if I just hit OK, Now I have a legend that I can place on my design area, and it's going to be a table, so you normally place it underneath it. And now I have this layer information that tells me all the hole types, which are indicated by these icons. The dot, the circle, and the X are different hole sizes, and what their sizes are, and whether they're plated or non-plated, and then how many holes of that particular size are on your design, etc., etc. Okay, so this is supplemental information. It's not necessary that this is this is only useful when you're generating a mechanical drawing from your Gerber files, and I'm going to show you how to do that. So it's supplementary. What the designer or the PCB manufacturer needs is actually just the Gerbers containing information just for the board here. Okay, so this is just supplementary. I thought I'd show you that real quick before we finish, in case you're curious how to do that. Okay, I'm done for sure this time for this video. Let's go ahead and finish it off so we can move on to generating the Gerber files.